Hey everyone, welcome back. This is Professor Xiao. The purpose of this video is to help you with a specific homework question. The question is hands-on practice, so let's go to a Jupyter notebook. All the demos in this video is based on the dataset YULP1. This video may use some of these packages, especially RE for regular expression, GenSim, and scikit-learn. Note that I use the NumPy random seed 1 and random state 1. After reading the dataset, here is the high-level information about the dataset and the columns included. I printed the first 10 rows of the data by selecting a few columns. We will be focusing on the review text column of this dataset, which includes each of the review texts. The first review text, the second review text, and such and such. Each review text is referred to as a document. This is how NLP programmers refer to the texts, and the entire column of review text will be called a corpus. Now let's look at a specific problem. In this video, I will explain what is feature names in the context of bag of words model. I assume that you have a good understanding of what is bag of words model. A bag of words model will produce a term frequency table or term frequency matrix. The columns of that table refers to the index value of the terms or vocabulary. That matrix is completely numbers. There are no strings or actual words. So how does a model keep track of what is the index value of each of the terms? It uses a vocabulary object stored as a dictionary, as shown on the screen. In a Python dictionary, you have keys and values. A dictionary is basically a list of key-value pair. The keys are strings. They are the actual term of the bag of words model, whereas the value corresponding to each term or each key is the index value for that term. And the index values will correspond to the column index of the TF matrix. The fact that the vocabulary is stored as a dictionary creates some challenge. For instance, if you would like to extract and print out the actual term whose index value you know, for instance, 10, you want to know which term has the index value 10. This is not something that dictionary can help. Dictionary allows you to quickly extract the value by using a key, but your task is to get the key by knowing the value. Dictionary doesn't work the other way around. So how to solve this problem? How to quickly extract the term by using the index value? Turns out there is a simple way to solve that problem. Here is the vocabulary dictionary again. Because each terms are unique terms represented by the dictionary, the index values are actually unique, so that the index value of each term or feature is unique. And because of this feature, we can potentially transform the vocabulary dictionary into a list where we store the term at a location that corresponds to the index value for that term. So by using a list notation, by indexing a list, or by slicing a list, you can get the terms by using the index values very efficiently. That is actually the way popular Python packages will help you extract the terms by using the index values. Let's go to the Jupyter notebook. Here is the bag of words model that has been trained. I assume that you have followed my several other videos about the preparations of the YULP data and how to start the bag of words model training. Assuming that you have trained a bag of words model like I did here, the count object is the trained model here after fitting the model into this dataset and after transforming this dataset to become a term frequency matrix. Because the model has been trained, it now has a vocabulary attribute which stores dictionary of the vocabularies. Let's print some of the values in the vocabulary and see. So you can see that this dictionary is very large. It has a long list of key value pairs. Each of the term or key is the features with the POS tag, as I talked about in the other video. The values are the index values of the term in the bag of word model. As I said, this is not helpful for you to get the term by using the keys, so we will use another feature of the model. The model has a get feature names which return a list in the format that I just talked about. Its index of the terms will correspond to the index values of those terms. So let's do that. I will extract a few of the values here. Let's say I will extract the term garden by using the index value of this, and let's see. There you go. By using the key, which is the index value, you get the term. In some of the other videos, I will be using the benefits of the feature names list in order to extract the terms. I hope this video is helpful. See you next time.